So we're just going to work with the quadratic function type problems and do them with Desmos using make this a little easier. It just looks a little differently sometimes. All right, so to start with, everybody go ahead and type in that. When you type in an exponent on Desmos, you can do it two different ways. Like I can put X, and then I can do Shift and the 6 key, and that will go up to an exponent. Or you can click this little keyboard, and if the exponent's a 2, you put a to the second power. If the exponent's some other number, you can put a to the b power, and then you just got to type in the exponent. To get out of the exponent ever, if your cursor's up there still, you hit the right arrow. So then we got minus 14x plus 24. In a lot of these cases, to kind of see the whole thing, you will have to zoom out some. So a couple things just to point out in this one. You got, your smiley face type shape there on your parabola, right? We should have known that because we had a positive a value, right? Then we've got 4 points that we really use for these problems. That's our y-intercept. Again, you should know that from the equation, right? But that's used in some of the problems, the starting amount or initial value. We have our zeros, and we have our vertex. Those 4 points are almost going to answer every problem we could have. All right, so what this can also do is if we had to factor this, yeah, you could do your magic X and factor it that way, but you can use the zeros. So you remember when we did the magic X, if we are looking for the zeros, we got to change the sign. Well, those are the zeros, so if I'm factoring it, I have to change the signs. So I got a positive 2 and a positive 12, so that means I got to use a negative 2 and a negative 12. That makes sense? That's really like the biggest thing with using Desmos is if you are looking for the factors, you do have to change the signs. Okay? Any questions on that one? All right, so go ahead, enter in that one. We got negative 16 x squared plus 48x plus 160. The bigger the numbers, and we got a 160 in here, the more you have to potentially zoom out if you want to see the whole thing. The farther you zoom out, the less like a curve it looks like. Makes it look a little more pointier. But you can see again, we got the same 4 points. We got our y-intercept, we got our vertex, we got our zeros. So in the case of this problem, this is one I put the negative 16 in front, so this would be like a ball being thrown kind of thing, right? What's the highest point or the highest the ball reaches? What's the maximum height here? Yeah, 196. The vertex tells you the maximum height. How long did it take the ball to reach the maximum height? 1.5 seconds in this case. How many seconds did it take for the ball to hit the ground? 5. Y'all can see basically any type of question we're asking or going with, Desmos will show you like those points. Those points are what we're using. Everybody kind of follow? Any questions so far? All right, go ahead and give this problem a try. Jason jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled with the function there, where t is time in seconds and h is the height in feet. How long did it take for Jason to reach his maximum height? one important thing with this one, you'll notice you got t as your variable in the function, right? T isn't going to work with Desmos. You got to use X. So to get it to show up on the graph, you got to use your X's and your Y's. All right, so who thinks they can give me the answer? How long does it take him to reach his maximum height? 0.5. He reaches his maximum height in half a second. So again, we got a C value of 480. That's putting us having to zoom out a good amount. But you can still see the maximum right there. Our maximum, or our vertex, in 0.5 seconds, which is a height of 484. All right? Everybody see, like I'm saying, like you put the graph in, gives you those 4 points. You got to figure out which one you're using. All right, so this one, we got a toy rocket. It's launched vertically upward from the ground, level with initial velocity of 128 feet per second. Then its height h after t seconds is given by the equation there. How long will it take for the rocket to return to the ground? Who thinks I got it? How long for the rocket to hit the ground? 8 seconds is correct. Where it hits the ground is going to be that positive 0, okay? The two zeros in this case are 0 and 8. That's where it was starting on the ground. Where it hits the ground again is at the 8 seconds. You know, we got a rocket, so it's going up a good amount from where it started. Any questions on that one? A little bit different here. We got one of the games at a carnival involves trying to ring a bell with a ball by hitting a lever that propels the ball into the air. The height of the ball is modeled by that equation there. If the bell is 25 feet above the ground, will it hit the ball? Or bell? Will it be hit by the ball? And on Desmos, you can always hit the little house to zoom back into the center. And then you might have to zoom out again or adjust it. The other classes, sometimes they zoom out too far, and that makes an issue. All right, so you can tell me, are we hitting the bell? Emmy? No? Why not? Yeah, so we hit the ball. There's your maximum height, right? It's getting to 23.7 and some 6s. So that's the maximum height the ball is reaching. We needed the ball to reach the 25 feet. That's not happening, so we're not ringing the bell in this case. All right? These are asking the same basic questions. They are, just looking a little differently on how we do them.